This is a video to go over one of the problem areas that people have when they start studying algebra, and that is a comfort with the idea of a fraction. One of the reasons that fractions feel confusing is that there's more than one way to write an equivalent number using fraction notation. Let me just use as an example here the number 1/2. If we take the number 1/2 and multiply the numerator by 3 and the denominator by 3, in other words, we're multiplying the top and bottom by the same common factor, in this case 3, then the numerator will be 1 times 3 is 3, the denominator will be 2 times 3 is 6. And so what we learn is that 3/6 is an equivalent fraction for 1/2. Now there are lots of models that make sense of fractions and make sense of this idea. I'm not going to draw a bunch of pictures here. There are links in the MyOpenMath to longer explanations for these things. But just briefly, think about what we normally would draw here would be something like a pie that has 6 pieces cut. If you were to take 3 of the 6 pieces, you have taken 1/2 of the pie. So 3 out of 6 pie pieces is the same as 1/2 of the pie. That's the general idea to most of the models that you'll see for this. When we apply that idea in reverse, it'll look familiar. It's the idea of simplifying a fraction. If I have a fraction like this, like 4/6, and I notice that the numerator and denominator are both even, so that means I know that they each have a factor of 2, then I can write 4 as 2 times 2, I can write 6 as 3 times 2, and then I see that common factor of 2 appearing, which I can cancel out, and it leaves me with just the 2 over 3, or 2/3. Now, a word of caution, the only reason that we can cancel the 2 here with the 2 here is because they're both connected to their respective pieces with the times symbol. It's only because this is times 2 and times 2 that I can cancel. One way to keep that straight is the fraction bar is, we can think of that as division, and we know that multiplication and division undo each other. So it makes sense that times 2 and times 2 on either side of a division symbol might be able to be simplified. And that is in fact what happens. That's not at all what happens when you do addition or subtraction. If these were connected with pluses or minuses, then all bets are off. You wouldn't be able to do that. The correct thing to do when we are adding and subtracting is to make your fractions have common denominators before you try to do the operation. If the denominators are the same, then the operation is easy. 3/6, 4/6 is just 7/6. In the same way that 3 apples and 4 apples is 7 apples. It's not. We're not really doing much arithmetic here. When the denominators are the same, we just do the operation on the numerator and leave the denominator as it is. Same thing with subtraction. The denominators are the same, so we just do the operation that's given, subtraction between the numerators, and we get the answer. Notice in this case 6/12, I reduced that to 1/2. If you're not sure about that, pause the video and see why 6/12 and 1/2 are the same. It's very similar to the examples up here. Now the rule for multiplication is a little bit confusing, and so looking at models are helpful for this. So I would encourage you, if you have never seen a model for multiplication of fractions, do look at that. As I said, there are some links in the MyOpenMath for that. But the rule that you end up deriving for this is that when you multiply two fractions, you just do the multiplication to the numerator and the denominator. Notice that is different than what we did for adding and subtracting. So for multiplication, we multiply numerators, multiply denominators. Now, what you'll notice that I do a lot of the times, and it's especially true when algebra creeps into it, is I'm not in a big hurry to simplify this. I don't see 2 times 9 and just write 18. And I don't just write 3 times 10 is 30. What I would rather do is think at this stage, before I've made these values big or complicated, to think about whether there's going to be any common factors. Remember, I can cancel out common factors. So before I make the numbers bigger, I want to consider what the factors are. So in this case, I would say 9 is 3 times 3. So instead of 2 times 9, I'm going to write 2 times 3 times 3. And of course, 10 is 2 times 5. So I'm going to write 3 times 2 times 5. When I write it like that, I can see the common 2, and I can see a common 3. And so I know from my first rule up there that I can get rid of those, leaving me just with 3/5. So 2/3 times 9/10 is equal to 3/5. Let's look at some practice problems. If you're feeling pretty good about it, I would pause here and try these problems, and I'll catch up with you. I'll do one of each of the addition and subtraction, and then I'll do the multiplication problem in detail. Okay, so the first addition problem already has a common denominator, so that one's going to be pretty easy. So let me go ahead and do the second one. Oh, I'll just write the answer down. So the answer to this will be 10 over 12, and 10 over 12 will simplify to 5 over 6. The second problem I'll do in more detail. These two fractions do not have the same denominator, but I know from my idea of equivalent fractions that I can create new fractions that are the same. I can create lots of fractions that are the same as 1/2, but to do that I have to multiply top and bottom by the same value. So that means I can create lots of fractions that are equivalent, and they will all have denominators that are multiples of 2. Now the same thing with 2/5. I can create lots of fractions that are equivalent, but all the ones I create using that rule will have denominators that are multiples of 5. So in order for these to have the same denominator, I need a number that's a multiple of 2 and also a multiple of 5. It doesn't matter what number it is, the smaller the better, just because your numbers will be smaller, but there's no wrong answer to this. So a common multiple of 2 and 5 is just 2 times 5, 10. That's a really cheapo, easy way to find one. There may be smaller ones for some other problems, but multiplying the two things together will always give you a number that is a common multiple. So I have to do this in 2 steps. The first step is to rewrite the problem so that the two things I'm adding are not these two fractions, but rather equivalents to these two fractions. So I know I want that denominator to be 10, so the first fraction should be multiplied top and bottom by 5. That's what's going to make the denominator 10. The second fraction, to make its denominator 10, I need to multiply top and bottom by 2. Now that fraction will have denominator 10. So if I do that multiplication, the first fraction, 1 times 5 is 5 over 10. The second one is 2 times 2 over 10. And so now I have a problem just like number 1. It's just the addition of two numbers with the same denominator, and that's an easy problem. So that's 9/10. We'll do the same thing here. The first one is easy because the denominator already is given to be the same. So 13 minus 7 is 6, and I will let you check that 6/24 is the same as 1/4. Now in number 4, I have the same problem I had before. These are not the same denominator, so I need to first get them to have the same denominator. I need a common multiple to 4 and 3. So as I said before, 4 times 3, 12, that will work just fine. If there is a smaller one, you could think about it, but 12 will definitely work. So to get the first fraction to have a denominator of 12, I need to multiply the top and bottom by 3. That's the only way I'm going to make that denominator equal to 12. For the second fraction, I need to multiply the top and bottom by 4. That's the only way to get the denominator to be 12. So I have 9/12 minus 4/12, which is 5/12. And finally, the multiplication problem. This is just like the other one. We multiply numerators, we multiply denominators. That's the rule for multiplication. Let me get rid of this stuff. Give myself some room. Like I said before, I'm in no hurry to multiply those things out. I would much rather think about any common factors I might have. So I know that 9 is 3 times 3. I know that's worthwhile because I can see a 3 down at the bottom. And I know that 20 is 4 times 5. And I know that that's worthwhile because I can see a 4 up in the numerator. So if I cancel these, the 4s will cancel. Those are factors of 4. The 3s, there'll be a 3 that cancels. And so I'm left with 3/5 again.